So our last section we'll look at for Chapter 9 is on hyperbolas. In your packet, I think it's section 6.4. Okay, so same deal, homework in the packet, but if you want to look stuff up in your book, it's section 9.4. All right, so I said earlier that basically ellipses and hyperbolas are very, very similar. The equations look similar, the definition looks similar. You just end up changing one thing. Okay, so I think it was Autumn told us at the beginning of class that an ellipse was a collection of points in the plane. Okay, plane just means it's flat, two-dimensional. Such that if you take any point on the ellipse and measure the distance to each foci and then add them up, it comes out as a constant. Anybody have a guess what one word we're going to change in that definition? And it's going to become the definition of a hyperbola. We're still going to be measuring distances to two foci. So we're still going to use the word foci. Yep.
Is that what we take out the word constant?
No, it's still, we're going to measure each distance, and it's still, something is going to be a constant. But yesterday we added the two distances together. Yeah? No, not necessarily. The two distances might be different that we measure. But when we do something with them, it's going to come out constant. Any other guess? Subtracting, yeah. So this time, when you measure the distance from a point on the hyperbola to the two foci, if you take those distances and subtract them, it will come out constant. Right, so we'll look at a picture of that. What does it always come out to? Well, the constant depends on the hyperbola. Okay, the constant can be different for every hyperbola. Okay, so here's an example of a hyperbola. Each curve here has a name we'll learn in a little bit. C and B, I've already told you, those are the foci. And if I measure the distance from E, which is a point on the hyperbola, to C, and then E to B, if I subtract them, it'll always come out in this one to 5.66. And I took the absolute value just to make sure it was positive. Right, so no matter where we drag it, okay, the two numbers here are changing, but if you subtract the length of the two segments, it always comes out to 5.66. Go over to the other part of it. Okay, same idea. Any question on that? So that's our last conic section. And this one's a little different than the other ones because to generate it, you actually need two cones placed end to end, like the points together, and you would slice it straight down vertically. All the other conic sections you can generate with just a single cone, either cutting it straight across for a circle, cutting it at an angle for an ellipse, cutting it at an angle for a parabola but coming out the bottom. That's your parabola. And then the last one is the hyperbola. Two cones, slice it straight down. All right, so the two fixed points that we're measuring the distance from, again, those are your foci. Okay, is this a term we saw yesterday? Transverse axis? Nope. So the term we had in place of that yesterday, what was the axis that connected the foci? It was the major axis. With a hyperbola, we call it the transverse axis. Okay, and the other axis also has a name. It's not the minor axis. And the way I remember the transverse axis, if you traverse something, okay, it kind of sounds like the word traverse. Traverse means to go across. Well, the transverse axis goes across the hyperbola. It connects the two parts. Okay? And we're going to get a name for them in a second. Okay? These two parts are traversed by the transverse axis. This definition should look very similar because it's the same definition read yesterday. If you make a segment between the two foci, find the midpoint of it, that's the center. Okay, we had exactly the same thing for an ellipse. Okay, what else do we have in an ellipse that we haven't mentioned yet? Okay, what else do you think I'm going to have in my hyperbola that we had in ellipses?
Vertices.
Yep, we have vertices. Okay, and I'll get to those in a second. Okay, the name of the other axis that's perpendicular to the transverse axis and goes right through the center, it's called the conjugate axis. Okay, so the conjugate axis never touches the hyperbola. Okay, and earlier, remember when I was saying we had these two parts of the hyperbola? They're not really called parts. Okay, they're called branches. Okay, so in this picture, we have a left branch and a right branch. Okay, that's something else that's a little different about a hyperbola. You can't sketch it without lifting up your pencil. Okay, parabola you can sketch, it's continuous. Circle is continuous, ellipse is continuous. Hyperbola is not. Okay, the best you could do is say each branch is continuous, but you can't jump from one branch to the other without lifting up your pencil. Right, and lastly, just like an ellipse, we also have vertices. And the vertices are where the transverse axis crosses the hyperbola. So if we take a look at the sketch, right there is one of your vertices, and right about there is another one. Okay, any questions on any of those terms? Some very, very similar to what we talked about with ellipses. A couple of them new. Okay, and it's not overly important that you know the exact definition. I don't think we're going to mention conjugate axis again today. Okay, we will mention transverse axis. Okay, I'll ask you what direction it goes. Okay, anything else people notice about this picture? There's one other thing that is going to be involved here that's not involved with ellipses. Yeah? The distance between the two vertices? We could talk about that when we discuss A. Turns out our definition we used for A yesterday, it's going to be the same today. And C as well. Okay, so what we talked about yesterday, that'll still apply. But something else here. Yeah, B's out for today. We're still going to use it, but visually, I'm not even sure what B would really represent. It's not the distance, the same distance we were thinking of. I have an idea what B might represent, but I don't think we're going to have time to look at it today.
The order of subtraction, depending on which side, well, which branch it's on.
Oh, when you, like for this constant?
Yeah.
Yeah, actually, because we take the absolute value, it wouldn't make a difference whether you switch that order. In fact, you're never going to find this number today. I don't really care what that constant is. But any other thoughts about something that's going to come up in this picture? What happens when you have a graph that part of it just heads off towards infinity? It just keeps going. What sometimes can happen? It doesn't happen with a parabola, but it happens in lots of different graphs we looked at. as that graph keeps going towards infinity, what can happen with that curve? Mm-hmm.
The curve can almost flatten out.
Okay, it can start to flatten out. That's getting towards what I'm thinking of. Yeah?
It won't show up on the graph because it's too like straight.
If you have a newer calculator, it should be able to draw it okay. Some older ones have trouble drawing things that are vertical sometimes. Or if you have to sketch a graph in two pieces, even mine has trouble with that. But back to like what Kanan said. Something about a graph flattening out. That means it could be doing what? Yeah? Could have an asymptote. Yeah. And anytime we sketch a hyperbola, there are two asymptotes in this picture. Okay, diagonal asymptotes. So first, I'm going to just show you all the stuff that is very similar to what we did yesterday. Okay, then I'll show you how the asymptotes work. Okay, so your center is at 0, 0. Your foci, negative C0, C0. That should all look familiar. Vertices. Okay. Notice I'm using the word transverse axis, not major axis. And you have an equation, and then you have some criteria regarding A, B, and C. Okay. Looking at these two boxes, what's different in these, either the formula or the criteria for A, B, and C from an ellipse? What's different? Yeah?
It's x squared over a squared minus y squared over b squared.
Yeah, so it's a minus. Okay, that's the whole thing that makes an ellipse into a hyperbola. Yep.
Also, that you're basically using the Pythagorean theorem to solve for the, in order to use the c squared, because in order to use the c, a, and b.
We're not subtracting b squared and a squared, we're adding.
Yep, today we're adding. I'm not really sure if, in fact, I don't think this is Pythagorean theorem. I mean, I know it's the letters. Yeah, it's the same letters we use. But if that helps you to remember it, you can think of it that way. So today it's c squared equals a squared plus b squared. And if I said a and c are pretty much what we did yesterday, what do you think a is? Visually, what's a? Distance from, yep, a vertex to a center. And what about C? Yep, distance from the focus to the center. And the last thing, I think the most helpful thing for sketching a hyperbola is to know where your asymptotes are at. Okay, so the asymptotes for this kind of hyperbola are very simple. They go right through the origin. So there's no y-intercept. And there's two of them. Okay? They have a slope of b over a and negative b over a. Right? So now a and b have another role, okay? Something else that we're going to use them for. Right? And this also gives us different kind of information I could give you. So if I said to you in a problem, here's your equation. Y equals 2/3 x is an asymptote. Okay? That would help you to maybe figure out A and B. Okay? If I gave you the slope of the asymptote. All right. Okay, as far as when we graph a hyperbola, I'm not going to do it this way. Okay, I think the easiest way to graph it is really just to draw the asymptotes. And what you're going to end up with is kind of an X shape. And then you're just going to put your hyperbola either in the left and the right part of the x, or the top and the bottom. Right? So that's how I'm going to sketch it. If you want to try to plot points, you can also do that. Okay, but I think drawing the x shape with the asymptotes is easier. Okay, and then we just summarize this. So A, again, is the distance from the center to the vertex, and C is the distance from the center to the focus. Right, so let's see if we can find the equation of this hyperbola. Okay, let's start by identifying A, B, and C, and then we'll go from there. Okay, anyone think they can tell me what A is? Yep, A is the distance from the center to the vertex, which is 2 units. Okay, what else can I get directly? C, yep. C is 3. And to get B, A squared plus B squared equals C squared. So A squared plus B squared equals C squared. Square root of 5. All right, now we need to figure out what formula we should use. Okay. Right now, there's no question we're going to use this one. It's the only one we have. But the other formula we're going to look at, let me show it to you, looks like that. Okay. And you don't have to write it down yet because we're going to come back to it. What's the difference between the one you have in your notes and this one?
You solve y squared and x squared.
Right. Today, you don't switch the A and the B. Okay? And you switch the Y and the X. What's that?
Order of subtraction matters.
Yep, the order does matter when you subtract. Yep. Okay, A is always the first denominator. B is always the second. That's totally different from an ellipse. With an ellipse, A is the bigger one. Okay. With a hyperbola, A is the first denominator, or A squared. B squared is the second denominator. Notice where your negative is. Okay. That's what I use to figure out which way the transverse axis goes. Whichever term is positive, that's where the transverse axis goes. If the y is positive, like it is here, transverse axis is vertical. If the x is positive, transverse axis is horizontal. Okay, so whatever letter is positive, that's the direction of the transverse axis. All right, let's see. To figure out your transverse axis, I would just think in your mind, if you graph the center, the vertex, and focus, how would they line up? Horizontally or vertically?
Horizontally.
Yeah. This focus is 3 units right of the center. The vertex is 2 units left. Okay. So using that, we can figure out what should be positive and what should be negative. Okay. Dominic said it's horizontal, so x squared is going to be positive. Right, so let's write down our equation. So x squared over a squared, y squared over b squared, and it still equals what number? 1. It's the same as an ellipse. Okay, so can somebody tell me what my equation would be? X squared over over 4. Y squared over 5 equals 1. Okay. So there's your hyperbola. Okay. In order to sketch it, I think the asymptotes, that's the most helpful thing. What is the slope of my asymptote? What letter goes on top?
B.
B on top, and on the bottom?
A.
A. Okay, so my slope, not the nicest number.
B on top.
Yeah, that's what I said, B on top. B over A. Okay, So those are the two lines we want to graph. What I would do for graphing purposes is change square root of 5 to a decimal. It's about 2.3, 2.2. So it's about 2.2 over 2x. Right, so I'm going to go up 2.2 and right 2. Okay, so that's what I did. Went up a little more than 2, right 2. Okay, up a little more than 2, right 2. Okay, and then also, don't forget the negative. So go down a little more than 2, right 2. Down a little more than 2, right 2. Okay, any questions on sketching your asymptotes? Hopefully at this point everybody can sketch just a line, rise over run. And now, which way does my transverse axis go? Yeah, goes horizontally. So just sketch your your hyperbola the best you can. If you want to plot your vertices, you can. Okay, they're at negative 2, 0, and where else? Yep, 2, 0. And just use those as basically how close you should get and kind of sketch from there. So we'll sketch that and like that. So there's our hyperbola. All right, any questions on that? Now, could you sketch that on a calculator in just using one function line? No. Okay, let's try to sketch it, okay, and see what happens. Okay, because if you get stuck on the test, you can always use your calculator to try to help you with the picture. Okay, how would I get y by itself here? Yeah, so I'm going to just subtract that as a 1/4 x squared. Okay, so I'll be left with that equals 1 minus 1/4 x squared. And then multiply both sides by 5. So we're going to get 5 minus 5/4 x squared. Oh, thank you. Yep, divide by negative 1. So what we can do is just switch the order. Give me negative 5/4 x squared.
It should be the other way around. It should be
No, it
positive
should be
5/4
5/4
and
x squared
negative.
minus
You don't want to mess that up. 5/4, yeah, switch the order. Don't change the signs. 5/4 x squared minus 5. And what's my last step?
Square root both sides.
Yep, square root both sides. And remember, because now we got the positive and negative, that's where you're going to have to sketch it in 2 parts. Okay, so let's make a sketch of that and see how the calculator sketches a hyperbola. All right, so we've got the square root of, let's do it like this. 5/4 x squared minus 5. And did I show you the trick yesterday for y2?
Just take the negative.
Yeah. Yep, the negative of y1. That's quicker. And let's do zoom 6. Okay, so the top part is y1, and the bottom part is y2. Okay, you might think it's actually good to see it in different colors, because you might think, oh, maybe it'll sketch a left branch and a right branch. That's not how the calculator does it. It actually sketches the top half of each branch and then the bottom half of each branch. And it should connect. Okay, but we've talked about that. Okay, any questions on that? Okay, it's the only one today I'm going to graph on the calculator. All right, so this one already have an equation, just wanting to discuss it. Okay, what's A in this case?
4.
Yep, it's always the square root of the first denominator. B, 2. And C, square root of 20, which is, what'd you say? 2 square roots of 5. Okay, which way does my transverse axis go? That's probably the first thing I would find.
That's
Horizontal.
Horizontal. Yep. Now I know everything is left and right of the center. So where are my vertices?
4, 0, 4.
Yep. Left 4 from the origin, right 4. How about my foci?
Minus or minus 2 root 5, 0.
Yep, plus or minus 2 root 5. Center?
0,
0,
0.
0. We haven't shifted it. And one more thing we have to find, asymptotes.
Plus or minus 2 or 4.
Yep, and you can reduce if, so yep, plus or minus 1/2 x. Okay, any questions on that? All right, so what's, same kind of question, just discuss it, but what's different here?
You've done it.
Yep. That's the biggest thing. It's not equal to 1. Before you even do that, could you tell somebody looking at that, I think it's either going to be an ellipse or parabola or hyperbola? How would you figure that? How come it's definitely a hyperbola?
So subtraction.
Subtraction. And why not a parabola?
Just
Squared.
Yeah. Okay. 2 variables that are both to the second power. Okay. All right. So how do we get this equal to 1? Divide by 36. Okay. And I'm going to get x squared over minus y squared over equals 1. Okay. What's A?
2.
Yep. B. And C. Square root of 9 plus 4, or 13. Okay, transverse axis goes which way? Horizontal. Yep. What's the center?
0, 0.
If I was doing it, this is the order I would probably think about it in. Find this, then the center. Now you're going to be left and right of the center. How many units to get your vertices? 2.
Plus or minus 2, 0.
Plus or minus 2, 0. How about foci?
Plus or minus 13, 0.
Plus or minus square root of 13, 0. And asymptotes. And what letter equals? Y equals. Okay, if you sketch an asymptote like I did on the calculator, or sketch the hyperbola, then you could sketch your asymptotes and see how, if you got it right. Okay. Questions on that? All right. Okay, so this is the case where the transverse axis now is going to be vertical. Okay, if you want to write it down, you can. It's all, it is in your packet. Same relationship between A, B, and C. But the slope of our asymptotes is going to change. Does anyone have a guess what the slope of the asymptotes is going to be? It was plus or minus B over A last time. It's going to be A over B this time. And it gets a little messy when we shift it from the center, but not too bad. We'll use point slope form for the equation of the line when we shift it from the center. So we'll have y plus or minus a number, and then x plus or minus a number. But I'll point it out to you, and I think actually for that one, I put the packet in the notes, so you'll see it on the board. Anybody else still need anything here? Right? A and C, exactly the same as what they've always been. Now you're just above and below instead of left and right of the center. All right, let's try to discuss this one. First thing I'd have to do to discuss this is what?
Divide by 4.
Yep, divide by 4. So you're going to get y squared over 4 minus,
X squared x.
yep, if you want to put a denominator, you can. And that equals 1. Okay, what's A? 2. B? C? Square root of 5. Okay, transverse axis, which way does it go this time? Vertical. Look at the letter that's positive. Okay, vertical. Where's my center? 0, 0. Vertices. Okay, foci. 0 plus or minus root 5. Okay, asymptotes.
Y equals plus or minus 2x.
Plus or minus 2x. Okay, I know we went through that one kind of quick, but any questions on how we got those? All right. Does anybody need me to do a couple more discussed ones, or can we go into the harder ones? No questions on how you'd find the equation of that parabola, hyperbola? Find A, find B? No? Okay. All right, so what we can do now is we can shift it. And we're going to be shifting the center. Okay, so our equations start to look like they normally do when we shift things. X minus h, y minus k. Again, notice h always is paired with x. K is always paired up with y. A always comes first, or a squared in the denominator, then b squared. They write the equation a little differently than I do. This is c squared equals a squared plus b squared. If you just move a squared to the other side. And now the asymptotes get a little bit more tricky, because now we have to write it in point slope form. Okay, the slope part is the same, but we have to shift it according to where we shifted the center. Okay, because the asymptotes go right through the center, always. That's why we shifted the asymptote by the amount we shifted the center. And here's a couple diagrams of each type of hyperbola. What do you notice if you look at the foci and vertices compared to, like, if you looked at the same kind of diagram as an ellipse? Does anybody notice anything about the order? It says F1, V1, center, V2, F2. What if you looked at that same order in an ellipse? Yeah?
The foci are farther from the center than the vertices.
In what conic section? In which conic section? In a hyperbola. Okay, in an ellipse, that's not true. In an ellipse, the vertices are the ones that are further away, and the foci are closer in. Okay, so that's a little different than an ellipse, and I think this picture shows that pretty good. Okay, but this is in your packet. This is table 4. I just took it right out of your packet. All right, so let's try to find the equation of this hyperbola. Okay, so your first step is you want to find all 5 letters. H, K, A, B, C. Okay, Nick, what? Let's start with H. What would H be?
1.
Yep, H is 1. Okay, Matt, how about K? Good, -2. Okay, David, can you give me something else I could find, either A, B, or C? Sure, we can find A. That's the distance from the center to the vertex. So what's A in this case? 2, yep. A is 2. One more letter I can find, but then I'm going to need a formula. I can find C, which is the distance from the center to the focus. 3. And then, how do we get B, Brian?
You do C squared, which is 9 equals 4 plus B squared.
Perfect. And if Brian just said bring the 4 to the other side, and you get B as the square root of 5. Right. When B is the square root, that's not bad because you're going to have nice vertices, you're going to have nice foci coordinates, and you're also going to have a nice formula. Okay, so don't worry about it if B is the square root. Okay, it doesn't mess things up. All right, find the equation. All right, what variable should be positive here? I think the X. How do we figure that out?
Because it's parallel to the x-axis.
Yeah, we want to think, if we were to draw all these points out, right 1 down 2, right 4 down 2, right 3 down 2. Think about how they're all lining up. Okay, horizontal. So that means I want the X positive, so I'm going to put it first. So it's going to be X minus H and Y minus K. All right, so it's going to be X minus 1. Good, yep. Over 4? Yep, Y plus 2. Over 5, and that all equals 1. Good. Okay, they didn't ask us to discuss it, so I'm not going to go through this vertices, foci, asymptotes, but we will do one because the asymptotes can be a little tricky. Hey, any questions on that? All right. So let's go to basically the hardest one we can have. Okay, one that's not written in the right form. They want us to discuss it. So first we've got to get it in the right form, then find all 5 letters, then we can discuss it. All right. Anybody tell me one step I might want to do first here? Do what? Okay, we can put the 11 on the other side.
And then put it in order, so X squared, X terms, and Y squared terms, Y terms.
Okay, I'm going to regroup it so the X's and the Y's are next to each other. And I'm going to do 2 other things at the same time. What else do we want to do?
Factor out.
Yep, we want to factor out what from the X squared? 1. And leave a little bit of space. And what about from the Y squared? Right? Positive 4 or negative 4? Factor out positive 4. And that'll leave me with?
Y squared minus 4.
Good. All right, what do we add to complete the square for the X terms?
1.
1. And what do we add for the Y terms?
4.
Yep. So what did we add on the left? 15.
Because they.
So we took away 1, and then we added 16. All right, let's see, now we can factor it. What's x squared plus 2x plus 1 factor as?
X plus
X plus 1 squared. Y minus 2 squared. And that would equal what?
4.
4. Okay, it's getting there. It's not quite right.
Solve the sign on both sides, multiply by -1.
You want to multiply everything by -1?
Because then
Divide
I get-
everything by -4.
Switch the x side and the y side, so it would be 4 y minus 2 squared minus plus 1 squared.
Yeah, that's what I would do. Write it in the correct order. The minus should come second.
Oh yeah, it's really
Okay, so there's your minus. Otherwise, this is starting to look like an ellipse. Okay, but with this minus, that's what makes it a parabola, hyperbola. So what do we have next?
X plus 1
Yes.
squared.
And then you divide everything by 4.
Yep, now divide everything by 4. And now we're going to get denominator for the y's is 1. How about for the x's? And it's finally equal to 1. So not too bad. Now we have our equation in the right form. What's h? -1. Remember, h is always the number after the minus sign with the x. Be careful because it's a plus sign. What about k?
2.
K is 2. A,
It's
1.
B, 2, and C, square root of 5. Right, so this is I think this is the hardest step, getting it in the right format. Now you've picked out all the important numbers. Now we can describe everything. Transverse axis. Yes, vertical. Let's do the center. HK, -1, 2. How about the vertices? They're going to be shifted above and below the center. How many units? 1 unit. What's 1 unit above the center? And what else? -1, 1. Now the foci are going to be shifted above and below the center. How many units? Square root of 5. So yeah, -1, comma 2, plus or minus root 5. Okay, and now the asymptotes. Okay, this is the part, and I never come up with a good way to memorize if it's A over B or B over A. Okay, so which one is it? Yeah, everyone agree with that? A over B? Okay. I don't know a good way to memorize that, but right, so we have A over B, and what do we have in parentheses next to that A over B? X. Yeah, A over B, X minus H, and Y minus K in front. That's the same in both. Y minus K, X minus H. It's just the slopes. All right, so we got X minus H, Y minus K. And that's just point slope form. If you don't like it in point slope form, we can change it to Y equals mx plus b when we're done. In fact, yeah, why don't we do that after we finish it up? What was K again? 2. Okay. A was how much?
1.
1, and B was 2. So 1 over 2, that's a nice number. And H? -1. Okay, so there's the equation of your asymptotes in point slope form. But what if you wanted it in y equals mx plus b? How would you change that? Yeah, I'd do it, you'd have to do it twice. Okay, distribute it as a positive 2. And then what?
Wasn't it?
It is 1/2.
It's 1 over 2 x plus 2.
Oh, thank you, 1 over 2. Yeah, that would mess us up.
And then 1.
So 1/2 x plus a half.
And
Add 2. And what's 1/2 plus 2? 2.5, or you could write 5 halves. Okay, so we distribute it as a half, and what else would you have to do?
As a negative 1/2.
As a -1/2. So it's negative 1/2 x minus a half. And what's negative a half plus 2? 3 halves, yeah. Okay. I usually like the asymptotes in y equals mx plus b, so make sure you're okay with distributing it and changing it. And that's it. Okay, it's a little bit time consuming. I don't think it's overly hard, but it just takes a while to go through all that. Okay, but there's nothing that's longer than that on the test. Okay, any questions on that one? All right. So that finished up everything we're going to do with conics. Okay, so the first half of the test is on conics. Second half, I think, is easier than this. It's on matrices and solving systems. Okay, so I think you'll find that a little easier. Okay, homework, pretty much the same exact kind of problems as last night. 13 to 16, that's the matching. 17 to 21, odd. 29, 31. A few graphing ones in there. 37 to 41, odd. And 53 and 55. Okay, that's all on page 411 in your packet. And tomorrow you will need your book for homework. Okay, we're done with the packet.